As huge as space is, the farthest man-made object out there is NASA's Voyager 1. Currently, this spacecraft is over 22 billion kilometers away from the Earth, which is approximately 156 times the distance between the Earth and the Sun. It is so distant that it has crossed over interstellar space sometime in 2012. Join us in this video as we explore the discoveries of NASA's Voyager 1. Voyager 1 has now gone beyond the Sun's helioscope, a boundary where the Sun's gravitational influence on an object is non-existing. Despite this, Voyager 1 still maintains strong communication between NASA's Deep Space Network, even till date. In its 44-year mission, it has discovered some interesting things beyond our solar system and beyond. So, let's dive into this, shall we? NASA created two Voyager spaceships in the 1970s, the Voyager 1 and the Voyager 2. Originally, they were designed to get a closer image of Jupiter and Saturn, but both spaceships have their missions extended and still function today. The two spacecrafts were launched in the summer of 1977, taking advantage of the rare planetary alignment of Jupiter, Saturn, Uranus, and Neptune, which happens every 175 years. This allowed the two spaceships to tour these planets with minimal fuel and less travel time. Both Voyagers would travel past these planets using gravitational assist called flybys. This was the way Voyager studied its target planets. Voyager 1's first flyby mission was Jupiter. This mission commenced 7 months due to its launch when the spacecraft was 265 million kilometers away from the planet. It started taking lots of pictures that over the coming year gave astronomers an amazing view of the jovial planetary system. Voyager 1 was the first to capture a color time-lapse movie which showed the 10 rotations of Jupiter. This made the astronomers discover that Jupiter's surface is more turbulent than previously understood, and primarily made out of hydrogen and helium. It also took a photograph of Jupiter's main ring for the first time. Other occurring missions have identified this ring as part of a larger ring system made out of moon dust, which extends far beyond the planet's atmosphere. Speaking of moons, Voyager 1 took images of Jovian moons Amalthea, Io, Europa, Ganymede, and Callisto, capturing amazing details of their terrain for the first time. It also discovered two new moons named Thebe and Metis. In earlier 1979, Voyager 1 performed its closest encounter with Jupiter at a range of 280 kilometers. All of Voyager 1's scientific instruments worked, except one, and despite the setback, the data accumulated during this flyby changed the planetary atmospheric models used by astronomers at this time. Out of all the incredible discoveries in the Jovian mission, the most stunning discovery by this Voyager 1 was the active volcanoes of Jupiter's moon, Io. Astronomers discovered that these volcanoes were powered by the expansion and contraction of its surface, as Io traveled around Jupiter in the elliptical orbit every 42 hours. This constant push and pull was able to generate enough heat to make Io the most active object in the geology solar system. This discovery also started a revolution in the field of planetary science. It forms the foundation of our current understanding of moons and outer space solar systems. Voyager 1 used Jupiter's gravitational assist to transport itself towards Saturn. It entered Saturn's planetary system in the late 1980s and immediately started sending in data that changed our understanding of the ring planet. The first discovery that Voyager 1 made about Saturn was the planet's upper atmospheric composition was 7% helium, compared to that of Jupiter's atmosphere. The rest is almost all hydrogen. Before this discovery, astronomers had expected that the atmospheric composition of Saturn to be the same as Jupiter and the Sun. However, the lack of helium in the upper atmosphere is because of the heavier helium sinking through the atmosphere of hydrogen over the aeon and collected in pools of liquid helium. This is what makes Saturn a true gas giant. Saturn is the only planet in our solar system less dense than water. This is amazing because Saturn is almost 10 times bigger than Earth and 100 times heavier. If there was a large pool of water, Saturn would float in it. Voyager 1 also captured Saturn's moons, which are Mimas, Enceladus, Tethys, Dione, and Rhea. Also, it has discovered 3 new moons, which are Pandora, Prometheus, and Atlas. Astronomers also discovered that these new moons clear a gap through the particles of Saturn's rings and create a type of space highway system for themselves. It also discovered a U-ring called the G-ring and revealed the beautiful structure of Saturn's complex ring system. Voyager 1's instruments also detected massive auroras around the equator and also around the polar latitudes of Saturn, which emitted large ultraviolet signatures. These auroras are made up of ionized hydrogen gas as energized solar wind passes through Saturn's magnetosphere. This discovery of auroras at Saturn's mid-latitudes is still a mystery to astronomers to date, as these giant light shows usually occur towards the polar regions of planets throughout our solar system. One of the best things that ever happened to Voyager 1 was its flyby of Saturn's largest moon, Titan. Its abundance of instruments like the interferometer allowed astronomers to peer through the moon's cloudy atmosphere. They discovered that it is made up of mostly nitrogen and methane with a surface temperature of -180 degrees Celsius and a pressure of 1.6 atmospheres. The pressure suggested that Titan may be the first body in the solar system apart from Earth where liquid is pulled from the surface. However, these lakes of methane instead of water tie into atmospheric methane in the presence of inherent nitrogen, which chemically reacts to methane to produce different hydrocarbons and organic compounds. This made Titan one valid candidate to have prebiotic life. It remains a high priority target for astrobiology even to date. Voyager 1's flight trajectory, which allowed it to study Saturn and Titan's rings at a close range, also sent it on a northern path out of the elliptical plane. Its primary mission ended in 1990 when it took a series of images looking backwards in our solar system from a distance of about 6 billion kilometers from Earth, famously known as the Family Portrait. The image featured 6 planets including Venus, Earth, and the 4 gas giants. From then, the spacecraft was handed to the Voyager interstellar mission known as the VIM team. The VIM was a 30-year mission extension, and throughout, Voyager's 1 antenna would constantly receive instructions and send relevant data on interplanetary and interstellar field particles and waves, aka FBW. More than 30 years have passed, and this mission is still going on to date. Also, Voyager 1 was instrumental in characterizing the status of our outer solar system environment as it went further away from us than the Sun. In late 2004, the spaceship crossed the termination stock boundary, a place where solar winds interruptedly slow down and heats up as it encounters interstellar wind from beyond the solar system. This crossing began the discovery of the Sun's helium sheath, which is a big bubble blown by our Sun to protect its interplanetary system from interstellar particles and radiation. Then, astronomers set out to search for the heliopause boundary, which is the outer limit of the Sun's magnetic field. Voyager 1 passed through this boundary around 2012. It was in interstellar space, now traveling over 61,000 kilometers per hour. This was the first time any man-made instrument performed measurements without being affected by solar particles and wind. At the time, Voyager 1 was at a distance of about 18,000 kilometers from the Sun. This crossing gave astronomers their first data sets to understand and analyze interstellar space. An example is the study of particles removed by other stars which measure interstellar cosmic rays and magnetic fields as they interact with the helium sheath and composition of the interstellar medium. As Voyager 1's interstellar mission started, the VIM team turned off onboard instruments so that the spacecraft could generate good electrical power for more science operations. Currently, it performs as the ultimate ultraviolet observatory that astronomers use to look at objects that destroy the solar system. Also, Voyager 1 would keep drifting into space, possibly endlessly, until it gets pulled in the direction of another star system or disintegrates and falls apart due to some complications. Either way, the importance of Voyager 1 in our human civilization is far-fetched. It is the first spacecraft that showed us our space and the whole universe with the famous pale blue dot image. Also, it carries only interstellar messages from human beings to any future space-like civilization that may discover it. Voyager 1's ultimate record is its vinyl disc, containing sounds and images which are selected to show the diversity of life on Earth. It is so interesting to think that if Voyager 1 exists in the nearest future and lasts more than us humans, a little part of the world would still be floating around the emptiness of space for someone to discover. That's all for today's video. If you enjoyed it, give it a thumbs up. And also, if you would love to get more astronomy facts and mysteries, don't forget to subscribe to the channel.